Hi everyone. In this session, we are going to learn how to implement the morphological transformation operations opening and closing. And we are going to do this implementation in OpenCV using Python. So for that, I'm going to use Spider. Well, I hope that you have already gone through our previous lectures, right? So opening Spider. Well, before that, I'll explain you what is morphological transformations of this opening and closing. Opening is just another name of erosion followed by dilation. So guys, you know that I already explained about erosion, what is exactly erosion, when to use erosion, what are the outcomes of erosion, right? Then what is dilation? Similarly, when to use and what are the outcomes. So opening means erosion followed by dilation. So it is useful in removing noise, as we already explained what in the case of erosion and dilation. And for that, we are going to use this CV morphology EX, this function. And here you can see that we are using CV morph open as one such parameter. About the kernel, I explained already. So CV dot morphology X, under this image as our original image, CV morph open for the opening, and kernel for that kernel that we have defined. Well, you got it that opening is same as that erosion followed by dilation. Now, why it is useful? It is useful for removing the noises. Now, what is closing? Closing is just reverse of opening. Means reverse means what? Dilation followed by erosion. And it is useful in closing small holes inside the foreground objects or small black points on the object. Now, for this also, same function we are using CB morphology X, EX, E capital, same parameters, but here we are going to replace this one with this one. This means morph close. For opening, we are using morph open. For closing, we are use morph close. That is cb.morph underscore close kernel, same kernel. Well, guys, I think this information is clear to you. Let me show you practically. Wait, I'm opening this. Well, this code is ready. I have written the code here. Import CB to SCV, import numpy as NP. Now, to intentionally add some noises, Gaussian noise specifically, I'm using this definition for this add Gaussian noise I have defined here. See, def add Gaussian noise image mean 0, standard deviation 25, STD 25, noise NP random normal mean STD image shape as type NP UNTS noise image, that is CB add image noise. This noise we have added, then return the noisy image. This portion you have to add for adding the Gaussian noise, right? Manually. Now, other thing that I would like to know, tell you that about what is noise, what are the different types of noises, I'll explain in this detail in separate lecture. Just sign in to my, I mean, just subscribe this channel so that you will get information about the upcoming lectures. Okay. So you will be informed shortly that about that lecture. Well, in that lecture, I'll go through each and every details of the noise, its types, and how to implement them. Means how to add noises in an image, different types of noises using Python in OpenCV. Well, let's come back to the code. This portion you got it. I have added this for adding Gaussian noise. Now, this is our original image. To read this, CB im read. This is the location, then not found. Then if not found, then this message will be passed. Now, kernel, I told you, I have defined kernel using this 5 cross 5 dimension, filling all with ones and P1s, 5, 5, and PU and T8. Okay. Now, noisy image, add Gaussian noise image mean 0 STD 25. See, we have defined here and we are using this particular function. Now, that image will be added noise and it will be stored in noisy image, this particular variable, right? Now, opening CV morphology EX noisy image CV morph underscore open kernel, then closing CV morphology X noisy image CV morph close kernel, closing to CV morphology X opening as CV morph close kernel. Now let me tell you the difference. In the first cases, opening is applied to the noisy image. Noise means we have first added noise, Gaussian noise to our original image. Then on that particular noisy image, we have applied opening operation. Similarly, for closing also, we have directly applied on that noisy image. But I'll tell you that that is not going to work because this closing is used to fill the gap over the means particular foreground object, right? Now, why it is not going to work, I'll show you practically. Then closing 2. Now, this time I am applying this closing operation over the opening output. See, opening is the variable where opening output is stored. Over that, we are applying closing 2. Now, this is going to work. And you will get to know for the output. Then showing the original image, showing the noisy image, showing the opening output, showing the closing output when it is applied over the noisy image, and closing output, that is closing 2, when it is applied over the opening image, right? Then wait key 0 so that we can just click the close button to close it. Then destroy all windows to release the memory. Now let's run this code. Well, it is running. Now this is our original image, right? This is our original image. This is the noisy image. Noisy image, after adding the noise, we'll get this. We have got this output, right? This is the noisy image. Now we have applied opening over this noisy image. Then we got this out. See how clearly it removes the noise. Yes or no? The noise is clearly removed. Now, over the noisy image, means this is the noisy image, right? We applied opening, we got this output. Now we applied directly over the noisy image, means over this image, the closing operation, and then we got this output. See what we have got? Can you tell me why? Because, in case of closing, it tries to fill the black portion, black hole portion over the foreground image. If you look at the noisy image carefully, you will see that these are the black points, black holes. And through closing, it tries to fill them, right? Tries to fill them. So you can see the 0%, that is being now 1. So this is overall made white. Means you cannot identify the foreground object. All become white like structure, right? Everything, every whole black holes being replaced. So that is not going to work. So after applying opening, what we got this output. Now apply closing over this output, then you will get this one, and this is a perfect one because whatever the holes exist, that is being replaced on the means foreground object. Now on that we got this closing of means output, right? I hope I have explained it everything to you about the opening and closing operation. And believe me, these two are very beautiful operation when it is the case of morphological transformation. For this removal of noises or various purposes, we can use them, right? So guys, if still anything you would like to know more, then don't hesitate to ask me through comments. So Dr. Dibba is signing out. Thank you. Bye-bye. Take care.